Hello students, welcome to my lecture. In this video I will discuss a question from the current electricity topic. The question: finding equivalent resistance and current in a given resistor. The question as follows: current through R2 is, so there is a network, from the battery there is a current I is coming. So after reaching here it will split into two parts, here and here. So then again this current will reach here, then again it will split into two parts. Then after reaching this current here, again it will split into two parts, one part here and one part here. So this R2 I need to determine. Okay, so you see very clearly where the current will be splitting. So say for example I1 will be the current will be here, the rest of the current will go here, I minus I1. Then when I1 will reach here, then again split into two parts. Let's say I2 will go here, then here this is I1 minus I2, rest of the current will go here. Then I2 will be coming here after reaching, let's say it will be I3 here, then I2 minus I3. See here, from here I2 minus I3 will reach, from here same I3 will reach I3, the same I1 minus I2 will reach here, same I minus I1 will reach here, finally all together will become I. This is the scenario here. So they are asking what is the current flowing through R2. So first of all you notice very clearly what is happening here. So this network 2 ohms and 4 ohms here, this 2 ohms and this 4 ohms, this 2 ohms and 4 ohms will be in series. So this will become 6 and this 6 with this 6 will be in parallel. Okay, so you can see that how I can draw there. So this is the R5, this is the R6, this is 3 ohms, this is R7 will come here, this is R3, then these two will become R1 and R2. Let us write R12 will be is of 6 ohms. Let us see R3 will be is of 6 ohms. So now notice this 6 ohms and this 6 ohms will be in parallel. When these two are in parallel, then again 3 will come. So this is the battery here, that I will not change. Then this is of 2 ohms here and this is of 4 ohms here, and again this is of 3 ohms here and this is of 3 ohms here. Again redraw the circuit, this 6 will be 3. So this 6 will be 3. With this 3 and this 3 will be in series, total will become 6. So that means the circuit will become something like this. So this 3 will be here. So this 3 is this 6 will be the 3 ohms. This 3 ohms and this 3 ohms will be in series. That will become again for me the 6 ohms. So 2 ohms and 4 ohms. So this is the scenario here. Now what happens here, if you notice the 6 ohms and 3 ohms, the 6 ohms and 3 ohms will be again parallel to with each other, then that will become 6 into 3, 18 by 9. So 18 by 9 will be 2 is coming. So then I draw again, this is my 4 ohm, this is my 2 ohm. So these two again will comes out to be 2 ohms. So here is my battery, which is of 8 volt. Now you notice this 2 and this 2 will be 4 in series, that 4 and 4 will be in parallel, that equivalent resistance comes out to be 2 ohms. So this 2 will be 4 and this 4 will be in parallel. So finally comes out to be answer R equivalent is. Then what is the current I from the circuit? The current I will be is equal to 8 divided by R equivalent, that will be of 4 amperes. This is I got here. So when this 4 amperes is coming here, 2 amperes will go here and 2 amperes will go here. So that means here how much current will be flowing? 2 amperes and 2 amperes will be flowing here. So from here the current I is coming, that is 4 amperes. So how much current will flow here? 2 amperes current will flow here. So the current 4 amperes will be coming. Out of that 2 amperes will go here. Rest of the 2 amperes will go here. So after reaching here, this 2 amperes only will divide here. So it is something like 4 amperes will be coming here. This is the I will be 4 amperes. Out of that 4 amperes, so this 2 amperes will be coming here. Then 2 amperes will be reaching here. After this 2 amperes will be breaking here. So it will break up here. So one is of 3 ohms and this entire thing is of 3 ohms. Here it is. This is 6 and this will become 3. 3 3 the 6. Okay. So this 3 is this 3. So now again the current will be divided some ratios here. So let's say the current I am taking here, it will be some X, and let's say the current will be Y here. Then they are in parallel. So 3 into X will be is equal to 6 into Y. 3 1 ja 3 2 ja. So X will be is equal to 2Y. Then obviously X1 plus X2 will be is 2 amperes. X1 plus Y will be is equal to 2 amperes. So that means 3Y will be is equal to 2 amperes. Y is equal to 2 by 3. So definitely X will be is equal to 4 by 3. X will be is equal to 4 by 3. This is the something I got here. I will substitute. The current X that is passing through here, this circuit. That X will be I am getting as 4 by 3 and Y will be I am getting as 2 by 3 amperes. That is important to me. That is the Y which is coming here. So that is the current here, it is 2 by 3 amperes. After reaching here, it will break into equal parts, 4 by 3 and 4 by half of 1 by 3, 1 by 3. So here the current goes 1 by 3 amperes. So and here also the current goes 1 by 3 amperes. Okay, I want what is the current passing through this R2 here. So answer comes out to be 1 by 3 amperes. Okay, so very simple. The problem is simply series and parallel combinations. Okay, so you remember one thing here. So when the two resistors are in parallel, let's say there is a current I is coming here. Some out of this I1 current or X part will go here and Y part will go here. I'll call this is R1 and I'll call this is R2. Then again come back I. So definitely I will be is equal to X plus Y, one rule. Then as they are in parallel, I1 R1 will be is equal to I2 R2. So from 1 and 2 I can solve for X and Y. So I will become X plus Y will be is equal to R1 by R2. So from here I will be is equal to take X common, R1 plus R2 divided by R2. So from here X will become I into R2 divided by R1 plus R2. So similarly, what is Y here? So similarly Y will be is equal to I into R1 divided by R1 plus R2. So like this I got the answer for X and Y. So when I current is coming here, it will split into two parts, X and Y parts. That directly I can calculate what is that X and what is that Y. Okay, so this is the easiest way. Remember how to solve this type of problems. This is the technique, this is the logic I am using in the entire concept in this problem. So series parallel problem. So once again I will explain, see here what is series and what is parallel problem here. Let us again I will explain here. If you notice clearly, so the current I is coming here. So then again back to I, the idea. So here the idea is very simple. This 2 ohms and 4 ohms will be in series with each other. The answer comes out to be 6 ohms. This 6 ohms and this 6 ohms comes out to be parallel. The answer comes out to be 3 ohms. So this 3 ohms and this 3 ohms will be in series. Again the answer comes out to be 6 ohms. Okay. Now this 6 ohms and this 3 ohms in parallel. So in the parallel, what is the equivalent resistance? 6 into 3 divided by 6 plus 3, that is 18 divided by 9. Answer comes out to be 2 ohms. So this is the answer comes out to be 2 ohms. Okay. So this entire thing will be 2. So now this 2 ohms and this 2 ohms will be in series. The answer is 4 ohms. Now this 4 ohms and this 4 ohms will be in parallel. Answer comes out to be 2 ohms. So the total current comes out to be I will be is equal to 8 divided by 2, that will be is of 4 amperes. Okay. In series, current will be same, I same. In parallel, V same. The current divides. The current through the first resistor will be is equal to total current multiplied by R2 by R1 plus R2. The current passing through the second resistor will be I into R1 divided by R1 plus R2. So this way I can solve this problem. I hope it is clear. Thank you. Thank you for watching my video. Please subscribe my channel. Don't forget like and share.